alkenes undergo addition polymerization? Let me show you an example using the simplest alkene, which is ethene. This is one molecule of ethene, which is also the monomer of an addition polymerization. If I have n number of monomer molecules, they will react with each other. At the end, an addition polymer is formed. The pi bond in the monomers will be broken. They all join together to form a polymer, with the structure in this bracket being called the repeating unit. We want to show that it is a polymer, so we have to use two dangling bonds on both the terminals. The polymer that is formed is named after the monomer. The monomer used here is an ethene. By adding the word poly in front of the name of the monomer, that would be the name of the polymer. So this polymer is called polyethene. The structure in the bracket is from one monomer molecule, so it is also called the monomer residue, meaning what is left in the polymer from the monomer molecule. This would be the structure that you draw when the question in the exam asks for one repeating unit. If the question asks for two repeating units, then we would have to draw another one repeating unit. Both the terminals are still dangling bonds. So this structure is showing us two repeating units. Now let me show you another type of addition polymer, which is made from more than one type of monomer. I used two different types of monomers in the second example, chloroethene and tetrafluoroethene. They are both alkenes, so both of them will react with one another to form an addition polymer. For addition polymer, which is made from more than one monomer, one repeat unit consists of both the monomer residues. So the one in green is the monomer residue from the first monomer. The part in red is the monomer residue from the second monomer. This is only one repeat unit. If three types of monomers are used, then you will see three different monomer residues in one repeat unit. And this type of polymer, which uses more than one type of monomer, is called copolymer or heteropolymer. Now, I would like to talk about how the pi bonds are broken and electrons are being shared between the monomers in the addition polymer. I'm going to draw a few monomers side by side. So imagine we have n numbers of monomers. When they react with each other, the pi bonds will be broken. You can see from the equation above, there is no pi bond in the addition polymer product. In these monomers, I show both the electrons in the pi bond. Now I will draw the polymer that is formed from them. Every time the pi bond in the monomer is broken, one of the electrons will go to the left-hand side of first carbon and another one to the right-hand side of the second carbon. So for the blue and the green monomer, pi bonds are broken. Two electrons from the pi bond, one go to the left-hand side of the first carbon, another one go to the right-hand side of the second carbon. One electron to the left-hand side of the first carbon, another one to the right-hand side of the second carbon. So now, two electrons are shared between monomers. Two electrons form one bond. We are using n number of monomers, so this chain will get longer and longer and longer. To show that a polymer is formed, you will draw dangling bonds on both the terminals. The polymer that is formed is a very large and long molecule. To shorten the structure that we are drawing, we will simplify this to a repeat unit in the bracket. The same thing will happen to heteropolymer. Even if we are using more than one monomer, all the monomers contain pi bond, and each pi bond consists of two electrons. Pi bonds in the monomers are broken. One electron from the pi bond go to the left-hand side of the first carbon, another one to the right-hand side of the second carbon, one to the left of the first carbon, another one to the right-hand side of the second carbon. Many monomers are used, so longer polymer will be formed. Electrons are being shared between the monomer. Two electrons form a new bond.